So now we look at Newton's third law of motion. And this law has different statements. One of them could be simply that if you have two objects and they interact with forces, then for every force that any object exerts on another, there is an equal in magnitude and opposite in direction. Reaction force. So if one object exerts a force on another, the other one will exert a reaction force on the first. The two forces are exactly equal, so if F12 is one of the forces, it's exactly equal to F21. So this would be the force exerted by object 2 on object 1. This is the force exerted by object 1 on object 2. So the two are exactly equal in magnitude and opposite in direction. Now let's see how this works. So let's suppose that you have a table, that's the floor, and you have a heavy table. Could have some things on it, so it's heavy. And here you have a chair which has wheels under it. There's no friction, and somebody is sitting on it, and that person pushes the table. Okay, should have been a little bit closer. So he pushes the table to the right. Now the table is heavy, and what you would expect is the person to move backwards. And that's what happens if you push. If you're on wheels, well, there's no friction. You push this way, you go backwards. Now earlier we saw that F equals ma, and the direction of acceleration is the same as the direction of the force. So because the acceleration is in this direction, there must be a force also in this direction. But where did that come from? The person is pushing to the right. It simply means that the table is pushing the person to the left. So this becomes the action force, this becomes the reaction force. We can even say that this is the action and this is the reaction, because any one of the two can be the action force and the other automatically becomes the reaction force. As another example, let's consider again a heavy object and a person again on a chair with wheels. So the person is sitting here, and we tie a string from here to here, and the person pulls the rope of this cable towards the left. And because this is heavy and a lot of friction here, as he's pulling to the left, the chair would move to the right, which means that the string is actually pulling this person to the right. And so what we would say is that in a string there's tension. The force in a string is called tension. The tension is in both directions at every point. So if you consider this point, this rope is pulling the table to the left, and at this point the rope is pulling this person to the right. And at any other point, instead of a rope, if you consider a chain, and if you're pulling, well, this is attached to a heavy object and somebody is pulling from here, then this particular link is being pulled in both directions. So the same thing happens in a rope. If you have a string, at every single point there's a tension which we write as a T in both directions. And when we want to see what happens to the table, we will consider the tension in this direction. We want to see what happens to this person, the tension is towards the right. Okay, and we'll look at this a little bit more as we go further. Now, Another example would be gravitation. So here's the Earth and here's the Moon. So the Earth pulls the Moon towards it with the force of gravity, which means that the Moon pulls the Earth towards it with a force that's exactly equal. Let's call that F2, then F2 is exactly equal to F1, or gravity. Both forces are exactly equal and opposite. Similarly, if this is the surface of the Earth and a person is standing on it, well, the Earth is pulling this person down towards the center of the Earth, and the person is pulling the Earth upwards towards himself. Now, because F equals ma, the mass of the person is small, he would have some acceleration, but the mass of the Earth is large, it's huge, so the acceleration would be extremely small, the product being the same. One last example. If this is the ground and a person is walking, so as he walks in this direction, he's actually pushing the ground backwards as he walks with his feet, and so the ground pushes him forward. The ground is huge, so it doesn't move. The force is the same, but it can't push the whole Earth backwards, so it pushes the person forward. But this force pushes the person forward because the person is not so heavy. Now, if you were like on a boat, a small boat in the water, and you were a person and you wanted to walk this way, so as you push the boat backwards, well, the boat does actually move a little bit backwards and you move a little bit forwards. So now we will look at equilibrium in the next video.